Hey YouTube, welcome back. Today we have new problem, jump game, problem number 55, and I guess problem is quite common in the last 6 months. It has been asked by Amazon 12 times, Adobe, Yahoo, or Google. It has been asked a lot, so yeah, it's a quite decent problem. The problem says that you are given an integer array called nums, and you are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. Okay, so let's just try to think about this one. Let's take this example and know how we can approach this problem. So we have this array right now, as you can see, and we return true because we can reach the end by we can reach the end. So from this position we can jump one time or two steps, one step or two steps, but we will jump one step. After jumping one step, we can jump one step, two step, or three step. We can jump directly 3 steps. So it's true, we can go there. If we went to this example, it will be false. Why? Because if we jump from here one step and we jump here one step, we can do it. If we jump one step and two step, also we end with 0. If we jump 3 steps directly, we end it with 0 also. So most of our solutions will end with 0. So we can't basically jump to the end. So because of that, we return false. And the way to solve this problem, there are multiple ways to solve this problem. Sorry. There are multiple ways to solve this problem. And what comes to my mind, we will use a recursion. So we use a recursive function that keep track every jump and know if we can find the end or not. And let's try to discuss how we can do this one. So let's create a recursive function. So we call it const. We call it can jump from position, and basically this one will keep track if we can jump or not. And maybe I will take a position as an argument. And we try to like this function will try to call itself over and over. For example, we have to try to call itself and try to try every possible solution to know if we can find or we can reach the end or not. And after that, I will gonna return it here. And we start in the first. Oh, sorry, no, this is not good. And we start in the first index. I guess 0. Can I make the yeah, let's make it 15. Yeah, I guess 15 is better right now. And let's just make it like that, so I can even make it bigger. Let's just go to 16. And yeah, okay, let's just okay. So right now we're calling this function. Let's see what we'll do in this function. This function will try to loop through each position and try to do all the possible solutions, also possible jumps, to know if we can reach the end or not. And as you can see, as the example said, that we start in the first one position, so we put the position 0. Before I go and before I continue code the recursive function, the most important thing is to think about the base cases. In my opinion, the base cases, it will be if we reach the end. So basically, if the position equals nums dot length minus 1. In this opinion, If we reach this one, I will return true, and that's it. And that means we reach the end. Otherwise, I will return false. No, let's keep. Let's not return false now. Let's just continue in the loop. So right now, I want to know the what is the biggest jump. For example, if I am here, like let's say that we have a specific array, and maybe I'm at 1, and maybe this one is 4 or 3. So basically, I can jump 3 times or 4 times, but I want to make sure that I am not crossing the nums.length. So I want to make sure, is the value of the jumps bigger than the nums of the length or not? So I want to know how far that I can go. So I will create a variable called const furthest jump. Okay, and it will equal math.min. And I guess there's I don't know what, I'm still coughing, maybe because of the dust. I don't know. Anyway, it will be math.min. The position that we have plus nums of position basically, if we have a position of 0, that means that we're already 0. So we have maybe 2 or 3 more. So we don't want to make sure, we want to make sure that we are starting from the actual position. So we put the position index, and we see if this position plus its value is smaller than nums.length or not. Nums.length -1. And yeah, so let's just because of this one, it's quite important, because I don't want to have any jump, like the value, we don't want to we don't want to find the value it's bigger than the nums.length. Want to make sure that we are within the nums.length. So I will create a loop. I'll create a for loop, and I'll say let next position and it will equals the position plus 1. Okay. And I will say next position should be less than or equal the farthest jump, and the next position should be plus plus. I guess maybe it's a problem from the mic or something. I don't know. Okay, so we have right now next position. Everything looks good, and it will start to get quite hard here. I will put 2 lines of code. If basically I will call the function that can jump from function on the next position. Okay, and if we can find, or if we can go to the end, we return true. Return true. Otherwise, we here return false. Let's describe what's going on here. First, let's just try to submit the code. Run the code first, and it worked. Let's submit the code and see if it will work or not. I guess I get limit exceeded because we're looping a lot and we're trying every possible solution a lot of times. I guess this because I get a time limit exceeded. However, we have because if you can see here, the time complexity of this solution, it will be O of 2 in power of n, so it's not the best one. But let's just try to describe the solution, because we will try to build the next solution based on this solution and improve this solution. So basically what we are doing here, first we try to find our base cases, and after that we try to find the farthest jump, because it's important to know that we don't want to go out of the nums.length. And here in this one, we're trying every possible single jump and run the can jump from position on it. So basically, the can jump function is an entry point for checking if it's possible to jump to the end of the based on the jump values provided in the nums array. Okay, inside the can jump, there is another function called can jump from position, which recursively checks if it's possible to reach the end from a given position. The base case for can jump jump position is when the current, as you can see here, is the current position is at the end of the array. So position equals nums.length. In this case, it returns true because the end has been reached successfully. If the current position is not at the end, the code calculates the furthest jump. The current position can make it basically, if the current position is not at the end, the code calculates the furthest jump the current position can make. Okay, as you can see here, this one. And sorry, it considers the minimum values between the positions plus nums of position and nums I guess nums the length minus 1. I guess maybe this is why it didn't work. Anyway, so if current position here, if current position is sorry. So basically we do this one. Okay, we got the same thing. Okay, never mind. So we do this one is to ensure that the jump doesn't go beyond the array boundaries. The code then iterates through from the current position to the furthest possible jump and recursively calls can jump from position for each next position. If any of the recursive calls return true, okay, it means that a valid path to the end of the array has been found, and the function returns true. If none of the recursive calls find a valid path, the function returns false. And this one. Finally, the can jump function is invoked with an initial position 0 to start the actual process, and I'm talking this one here. So yeah, that's it for today's video, and this for today's solution. And in the next solutions, we'll try to improve this solution and to make it work in a better way. So yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you guys in future problems.